All right. So, Levi. Okay. So this is our last section. This is our last section in chapter 7. So, whenever we end this, whether we get done today, I'm not sure if it'll be today or tomorrow. My guess is today, but I don't know. You'll have a test 2 days from now, or so. Not a test, a quiz. Guessing a quiz on Thursday. Test on Monday next week. Okay, that's my guess. I'll tell you by the end of the hour for sure. Yep, it just is what it is. Quiz on Thursday is my guess. Test on Monday. So we're talking about matrix operations. So we talked about using matrices to solve systems of equations. Now we're going to talk about, like, you can add and subtract matrices and you can multiply matrices. So we're going to talk about those things. So I want you to, we're going to write down 4-ish matrices that we're going to use. So I want you to write these down so you can refer to them. Trying to make these decent numbers. 2, 4. Okay. So I want you to write these down. My paper isn't going to last long. You'll need to be able to refer back to them because I'm going to turn the page in not too long. So there are some things in math that are pretty logical. Once you realize what a matrix is, you should be able to add and subtract one pretty easily. So, for example, if I asked you to do B plus C, okay. If I asked you to do B plus C, what do you think the first row would be? Just if you take a guess.
2, 7, 4. What?
Oh my goodness. Christian?
What?
What do you think? First row.
3,
3 and 2?
Oh, B plus C.
Yikes. B plus C. B plus C. And Christian's right. It's 3 and 2 because all you do is add those corresponding things. So if it's in the first row, first row, first column, first row, first column. So this is going to be 3, 2, which means the bottom row will be what? What would be the first one in the bottom row? 1, -3, right? We need to add another matrix here because it does not give us enough stuff to do. So let's do 0, 4, 7, 8. Okay, so why don't you please find for me C plus E? Okay, C plus E. Okay. What do we got? Top row. 2, 1. Bottom row. 6, 8. Okay, we're not going to do any more examples of that because it's pretty easy. When you add matrices, you add the entries that are in corresponding places. So if it's top left, then you add the top left ones. If it's top right, then you add the top right ones. Okay, how about, why don't you try B minus C for me? B minus C. Okay, top row. Mm-hmm. Yep. Okay, so when you guys, just all the things with negative numbers, right? Just be careful that when you're subtracting a negative that you're adding, right? So 1 minus 2 is -1. 5 minus -3 is 8. 2 minus -1 is 3. -3 minus 0 is -3. Okay, adding and subtracting, super easy. Okay, now A plus E. Takes longer to put it in your calculator than it does to add it, though.
What?
It does. Yep, A plus E. What do you think? Okay, so
1, 6, 4. Yes. 7, 7, 3.
I'm gonna tell you no.
Do you have it?
So let me ask you this question. What you guys are trying to do is you're trying to add this and this, but
Is it 1, 6, 3 in the top?
it's 1, 6.
Oh, wait, I got 3 for A, not 4.
Okay, 1, 6.
1, 6, 4.
But there's nothing to add to here. So listen, what you're doing essentially when you're attaching these guys here, right, is you're assuming there are zeros in those spots. Okay, is this, with this inclusion of the zeros, is that equal to matrix E? So the answer to this is that it's not possible. That's why I put the question mark there instead of the equal sign. Okay, so it's not possible because you could, like, I understand, and you guys, you're not the first class in a million years to do this, because people are like, well, I'm just going to add them and I'll tack the 4 on the end. But if you're tacking the 4 on the end, you're assuming there are zeros here, which if you put zeros there, now it's not matrix E. Okay, so what has to be true if you are going to add or subtract a matrix? What has to be true? What's that? Same dimensions. Yep. Okay, so they must have the same dimensions. Actually, we don't divide matrices. So there's no division involved. Okay, so adding and subtracting, you must have the same dimensions to add and subtract.
Yeah. It says error dimensions match.
Yep. Okay, now let's talk about scalar multiplication. Huh? Scalar multiplication we've already talked about with what other topic? You probably don't remember what it is. Which is when we do
Don't remember what it's called.
vectors.
Yep.
Okay, so we did scalar multiplication with vectors, where you multiply the things. Scalar multiplication with matrices is the same. So if I asked you to do 2a, if I asked you to do 2a, pretty easy. Okay, and because it's a scalar, just one thing, changing the scale, that's why it's called a scalar, so don't freak out on the word, okay? We're just doubling this matrix. The size of it doesn't matter. I can double whatever I want to double. What's the answer for this?
2.80,
Yep. Okay, scalar multiplication, super easy. Okay, you can have a negative scalar, so let's go negative for e. Okay, what do you get for negative 4e? Okay, you guys questions on scalar multiplication? Super easy, also logical. So there's that one. Now, we're going to talk about something called a matrix equation. So this is different than using a matrix to solve a system. We're using our matrices that we have up here. So we're going to say that B, C are the matrices above. Okay, so these guys up on the top, we're using the B and the C. Solve for matrix X. So let's say we have 2x plus B equals C. So I want you to think about if it was an equation and B and C were actually numbers, how would you solve for X? What would you have to do first? You have to subtract B. So we still are operating the same way, but we now have matrices to do. Yeah, just a second. So 2x is equal to, you have to figure out what C minus B is, so go ahead and do that. I cannot get C and B on the same screen, sorry. So C minus B. Okay, C minus B is what? Yep, correct. Okay. Now, Javon was listening to me, which I appreciate. We don't divide matrices, okay, but this is a scalar, so I can multiply this by what? To get rid of the 2. Yeah, I can multiply by 1/2. So then matrix X is half of this. So then it would be 0.5, -4, -1.5, and +1.5. Do you guys have any questions on this? Because if we're okay, I'm going to move on. It's like solving this, getting an X by itself. What do you have to do? Subtract, just like if it was an equation and these were numbers. Okay. All right. So the last thing we're going to talk about, and this is the thing I want to spend the most time on, is multiplying two matrices together. Now, in the interest of full disclosure, your calculator will do this. I would like you to pay attention to what we're talking about, because you need to understand what's going on. Number one. Number two, it's the extra credit. So it's worth your time to pay attention. Okay, so we are going to multiply matrix B times matrix A. Now, if you look at the dimension of those, you're going to feel like it shouldn't be possible, but it is. We'll talk about how you know after we talk about how to do this. 1, 2, 4, 0, -1, 3. Okay, so we're going to do B times A. Okay, this requires you to pay attention. So of all the things that we're doing, this is the one that's the weird one. Okay, so do you remember how in vectors, the dot product was weird? We multiplied the x's, we multiplied the y's, and then what did we do with them? We added them together. There's echoes of that in this also. Okay, so there's addition involved in matrix multiplication, multiplying two matrices together. Okay, so here's what you do. The idea is that you take the first row here and you multiply it by each column. Okay, so let me show you. So I'm going to take this guy right here, two numbers there, right? And I'm going to multiply it by this guy. So you're going to kind of imagine like two fingers like a plug, like there's my 1 and my 5, and I'm going to turn them and plug them back in. So the 1 gets multiplied by the 1 and the 5 gets multiplied by the 0. Okay, so first spot in the row, second spot in the row, first spot in the column, second spot in the column. Okay, so this guy needs to match this guy. So it's 1 times 1 and 5 times 0, and we actually add those together. So multiply the two, add your final answer. In this case, we get 1 because this is 1 times 1 plus 5 times 0. That goes in the first row, first column of the answer. So I'm multiplying the first row times the first column. So it goes in row 1, column 1 of answer. Okay, now I'm going to do this again. So I'm going to take this row and multiply by the second column. So I'm multiplying 1 times 2 and 5 times -1. Okay, so in order, firsts, seconds, and then add them together. So it's 1 times 2 and 5 times -1, which gets you a total of what? -3. That goes in the first row, second column, because right here, first row, second column. Okay, and then I have to do one more because I got one more column I have to multiply. So first row, third column. Take a second and figure out what that would be. What number would that be? 19. Because 1 times 4, 5 times 3, add them together. So 4 plus 15 is 19. Okay, now that's the end. I've run out of columns to multiply, so I'm done. I'm closed my matrix. Now, what you have to do essentially is repeat the process, but with the second row in each column. Okay, so we're going to multiply this guy times those, and times those. Same process, multiply, add, and put your answer where it goes. Okay, so this one's going to be 2 times 1, -3 times 0, which is 2. Okay, why don't you fill in those other two for me? Okay, what's in the second row, second column here? I think it's 1. Okay, so 2 times 2 is 4. Nope, miss a pause. Is that a negative one? Oh, I missed it. Okay, my bad then. 7 then. Okay, I wrote over my negative. Okay, and then what do you get for this one? Negative 1. Yep, so 8 and negative 9 is negative 1. Okay, now let me have you try this. I want you to multiply b times c. Okay, using the same b and c that we had. So we've got 1, 5, 2, negative 3, 2, negative 3, negative 1, 0. Okay, I want you to try that multiplication for me, please. Okay. I gotta think about this just a second. What's the first row, first column answer? Yep, negative 3. Okay, so we're multiplying 1 and 5 times the 2 and the negative 1. So 2 and negative 5 added together. What's the next one? Yeah, also negative 3. Okay, and then bottom row, 7. Yep. Okay, now we need to talk about when you can multiply 2 matrices because it's limited. So for example, there's a property of numbers. Just want to run this by you. There's a property of numbers that says that 3 times 2 is equal to 2 times 3, right? We know that you can multiply numbers in any order. That's called the commutative property of multiplication, which doesn't matter to you, no, other than in practice, you can multiply in whatever order you want. First of all, matrices do not have that property, okay? Because if I were to multiply in the other order, so 2, negative 3, and negative 1, 0 times 1, 5, 2, negative 3, I'm switching what numbers I'm multiplying. So this first row, first column would actually be negative 4. This would be 19. This would be negative 1. And this would be negative 5. So not even remotely the same. Matrices don't act like numbers. Okay, so matrices are not commutative. First of all, that b times c is not equal to c times b. Not only that, b times a is not only not equal to a times b, but you can't even multiply a times b. It's not possible. Okay, so here's why. So I'm going to write down. You don't have to if you don't want to. Just illustrating my point. So a times b is 1, 2, 4, 0, negative 1, 3, and b is 1, 5, 2, negative 3. Now, I'm telling you, you can't multiply this. My question to you is why? Why?
Because there's something to multiply with.
Right? There's nothing to multiply.
Everybody raise your hand,
Right here,
When do you ever reach your units?
I just did.
He did actually.
Oh, just kidding.
Like here, I've got multiply the 1 and the 2, but there's nothing here. So it is all about, I told you when we talked initially about matrices that dimension is important, like to know your dimension is important. This is why. So the dimensions of the matrix, if you're going to multiply them, they have to have specific characteristics. So we can put this to two ways. The number of columns in the first matrix, right? So this has 3 columns, has to match the number of rows in the second one. Okay, because otherwise you don't have enough numbers to multiply. So let me show you that in practice. So when we multiplied B times A, what was the dimensions of B? What are the dimensions of B? 2 by 2. We multiplied that by A. What are the dimensions of A? 2 by 3. Okay, it's rows, columns, rows, columns. Those two numbers have to match. If they don't match, you cannot multiply. Okay. Now, here's the other thing. This is a little bit fancy, but it's not super fancy. What's left over here gives you the dimensions of the answer. This answer is 2 by 3 because that is what's left over here. Okay, so this has a 2 by 3 answer. What's left? B and C worked because it was a 2 by 2 times a 2 by 2. Okay, these are the same. The answer is a 2 by 2. A times B does not work because it's a 2 by 3 times a 2 by 2. Those two are not equal. So take a look at your ones that we have at the top. My question to you is, can I multiply A times D? Can we multiply A times D? What are the dimensions of A? 2 by 3. What are the dimensions of D? 2 by 4. Okay, that's a no-go. These are not the same. Okay, now, just a second. I gotta think about this. I'm gonna give you one more here. Okay, my question is, can you multiply those two matrices? Okay. You can multiply those matrices. What will be the size of the answer?
3 by 3.
It's a 1 by 1, right? This guy, what's his? This is why that little trick is handy to know, because otherwise you're like, what numbers do I put places? Sorry, let me think. What is the dimensions of this one? This is a 1 by 3. What are the dimensions of this one? 3 by 1. Okay, those match, leaving you a 1 by 1. So it's really just those 3 times those 3, and your answer is literally a single number.
Nice.
Okay, what would the answer to that one be? Or the number that's in there? No. It's -1, right? This 2, 0, -3. So -1. Now, real quick, I do want you to know that your calculator will multiply matrices. On your homework, I want you to do a couple by hand. The other ones you can do with your calculator, and there's not very many because it's just putting in your calculator. So let's say I'm just going to do this one down here. You just got to edit it, so you know how to do that. This is a 1 by 3. So 1, 2, 3. And then you got to go back in. You got to use a second matrix, though. That's the deal. So this guy's a 3 by 1. And 2, 0, -1. And then you got to use the matrix menu. So first one times the second one. There you go. Honestly, that one was the size. It takes longer to type it in. Okay, you get to the big ones though, and you definitely want to use your calculator. Okay, so your calculator does that. It will give you, if you try to multiply something that can't be multiplied or add something that cannot be added, it will give you an error that says dimension mismatch. Dimension mismatch. Okay, so not spending a ton of time on this homework because it's not super hard. Actually, I'm going to take off 13 because that's easy, but I'm adding a different one. Just a second.
Go add what you know.
Take away a different one, not a harder one.
34. I took off one that's more work. Like 15 is a decent amount of work. It has 4 parts to it, or 13 is, so I took it off. 38, 40, and 41. I want you to multiply these guys by hand. And then 50. Okay. Gold Star Club. 15. 32. 34. 38, 41, 50. Okay. There you go. So, quiz on Thursday, test on Monday. And you guys, I know Monday tests aren't your favorite, but it's matrices and then solving systems, so it's all stuff that is pretty easy. And I'll get you the paper that lets you know what's on the quiz tomorrow, but it's all matrix stuff, so I will double check.
It does, that is good. Exercises.
Did you read the instructions, you know?
Well, we were reading the instructions for the wrong one.
Well, there you go. That would not be good.
3A, so you have to.
Thanks, Larkin.
What does? Versus okay. Okay.
Did you do the homework that you missed while you were gone?
Yeah.
Page 523. 62, 63, 66, and 72. Are you going to do that one?
Yes.
Don't look at me like that. It's on Google Classroom. It needs to be turned in tomorrow if we're going to do it. Okay.
Yeah,